Pavlov is one of my favorites, or classical conditioning, I say, because we include John Watson in classical conditioning as well, but definitely one of my favorites. That and operant conditioning are probably my two favorite parts of psychology. So looking at just kind of a brief roadmap of Pavlov's discovery, we look at core terms like the UCS, UCR, CS and CR, the UCS, unconditioned stimulus, UCR, unconditioned stimulus response. The CS is conditioned stimulus and the CR is a conditioned response. So we look at timing, we look at higher order conditioning, real world applications or therapy. All of this is included with understanding the basic principles of classical conditioning. Pavlov's discovery had a really big impact in the psychology world. And his studying digestion, he noticed that dogs salivate to lab cues. And so he coined the term conditioned reflex. And then in this landmark shift, he showed how associations form under controlled conditions, which is the foundation for the behaviorist science as well as modern learning theory. And kind of the big idea here is that the neutral stimuli can gain the power to elicit responses through pairing. And that's at associative learning, right? And so with the classic, bell and food theory, we see that association, right? The dog starts to associate the sound of the bell with food, and so we get that unconditioned and conditioned response from that. And so what I mentioned on the last slide is kind of what we see here. The UCS or US, depending on where you're reading this, is the unconditioned stimulus, right? And that's what naturally elicits the UR or the UCR, which is the salivating. So we present the food and then the dog naturally salivates. The CS is the conditioned stimulus, which starts off as neutral, right? And it's only after we pair it with the UCS that the CS starts to elicit the CR, which is the salivation. So we bell, food, show the food, ring the bell, bell, food, bell, food, bell, food, over and over again, tying these or associating these two together. And then the dog starts to elicit the CR, which is the salivation, which is the same thing as the UCR. And there's another PowerPoint I have that kind of covers the basics of the learning theory chapter. If you look on my channel underneath, I think I just have it saved as learning or learning theories. It goes into a little bit more detail. Acquisition depends on the pairings, as well as contingency, and timing is also important. So just to kind of drill this in one more time, UCS or US, okay? It could be either way. UCS, US is the unconditioned stimulus. Think of something that happens natural. You don't have to prompt or teach. It's just a natural stimulus, something that happens naturally in the environment, and it gives you a natural response. UCR, unconditioned response. The conditioned stimulus or conditioned response is something that would not elicit a natural response. And so it has to be paired with the unconditioned stimulus in order to get a response. Either way, we want the responses, the R's, to be the same. We want this unconditioned response and the conditioned response to be the same. We just want to get that same reaction from two different stimuli. And we do that by pairing them or linking them together. So let's look at another example, okay? We have eye blinking condition. You have a puff of air, which is the unconditioned stimulus, which is going to elicit the UR, which is a blink, or UCR. And then there's a tone, right? The tone is the CS. When you first hear this tone, there's no response, there's nothing, because it doesn't mean anything, right? It becomes a blink, a learned blink, after we pair the two together. So we blow the puff of air, make the tone. Puff of air, tone, puff of air, tone. We're associating these two together. So our UCR and our CR are both going to be blinking. The conditioned suppression, or CER, is the CS is paired with the shock, and it reduces ongoing behavior. Something like letterpressing, or, but we're going to see less of this ongoing behavior. It's measured via suppression ratio. And so the skin conductance response, or the SCR or EDR, We have the CS, conditioned stimulus, the UCS, or US, the unconditioned stimulus, and these pairings, right? This change or autonomic arousal, like something like a sweat gland activity or something like that. That would be like the skin conductance response. And then we also have taste aversion, to throw another, sense in there. And so that's like often a single trial learning with long conditioned stimulus, unconditioned stimulus gaps, or like a novel flavor like nausea, something that's highly adaptive. So the idea here is that the CS becomes a substitute for the US in the brain, and so the CR starts to resemble the UR. And so in the examples like the salivation or the eye blink, the skin conductance response, all of that elicits the exact replica of the UR. The problems with the theory is that not all features of the UR are transferred to the CR, and not all features of the CR are part of the UR. And sometimes CR is opposite of the UR, the conditioned compensatory responses, and so there's this alternative theory out there called sign tracking. What we see here is the SS versus the SR. This was in 1973, Rescorla's experiment. So the SS would be the CS and the US link. So the conditioned stimulus and the unconditioned stimulus. And then we see the change in the unconditioned stimulus value after learning the unconditioned stimulus de-evaluation. And then the conditioned response drops. Okay, that's the evidence for the SS. The SR is the direct conditioned stimulus response link, and so the conditioned response would persist despite the unconditioned stimulus devaluation. And so we're taking away like organisms that encode the CS or the US expectancy, so something that's not just a reflex chain. So some just kind of basic conditioning phenomenon that we see here is, or terminology, is acquisition. The conditioned response strength grows with effective conditioned unconditioned stimulus pairing. When we see extinction, the conditioned stimulus alone to the conditioned response declines, right? So we're learning, the learning of an unconditioned stimulus is then absent. And extinction is going to set in. That's why I said earlier, like timing is important. You have to occasionally throw back the food, right? Throw the food back into the experiment if you want the dog to continue to salivate to the bowel, right? If you go too long without occasionally throwing it in and repairing those two stimuli, then extinction sets in and you're not going to see the dog salivating anymore. Spontaneous recovery is when the conditioned response returns after rest, so like a disinhibition, something temporarily restores the conditioned response. And then there's a rapid reacquisition, which is a faster relearning after extinction happens. So the subject can relearn it again, and oftentimes will relearn it faster even if extinction has set in. The conditioned inhibition is cues that predict absence of the unconditioned stimulus or conditioned stimulus, and so it passes summation. Generalization and discrimination, these responses spread to similar cues, and so that's sharpened by training with the S plus or S minus is how we would sharpen that a little bit more. And so, generalization or discrimination. So generalization is if we can show a bunch of objects that are similar to each other and get the subject to identify all of them. We see this in John Watson's theory with generalization. He makes little Albert scared of like white furry things or just furry things. There's like a white rabbit, there's a rat, there's a fur blanket. And so little Albert is generalizing in that experiment with all these objects. And so then John Watson bangs this loud noise behind him, which little Albert is scared of, which is our unconditioned stimulus. And then when he bangs that loud noise, he's, showing little Albert all these items. And so little Albert starts to generalize, right, among all of these. He's not discriminating between the differences. Timing, like I said, is so important in classical conditioning. And the rule of thumb is that the conditioned stimulus predicts the unconditioned stimulus. The excitatory, the conditioned stimulus kind of predicts absence, the inhibitory. And so the temporal coding hypothesis means that learners encode when the unconditioned stimulus occurs relative to the conditioned stimulus. And then we see correlations or contingency that matters more than mere like just the near contingency of it. And so we see optimal ISI that depends on the response system that we're presenting to our subjects. Second order conditioning is when we see a transfer of a CR from one CS to another. And so a CR transfers to a new CS by pairing it with a well-trained first order CS. And so there's no unconditioned stimulus that's present. And Pavlov has the metronome, which is the CS1, the food is the UCS, and then the black square, which would be the CS2, the metronome, which is CS2, elicits salvation. And so when we evaluate the conditioning, we are liked or disliked the valence transfers via the pairing, so like advertising or attitudes, something like that. When we look at classical conditioning outside the laboratory, we tend to look at classical conditioning and emotional responses, like fear, preferences, something that we can develop via pairing. And so there's different applications in behavioral therapy, systematic desensitization for phobias, virtual reality therapy, aversive counter conditioning, and then treatment of nocturnal enuresis as well. And we'll discuss some of that on the next few slides. Systematic desensitization has three parts: the relaxation skills, the anxiety hierarchy, and then gradual exposure while relaxed. And the mechanism would be the CS, the conditioned stimulus, the feared cue. It's repaired with the calm state, therefore weakening the fear response. It can be imaginal, in vivo, or mixed. It can track SUDS, ratings in order to try to monitor the progress as well. Typical success rates of about 80 to 90% is what we would see here. With virtual reality therapy, VR delivers kind of a graded, controllable exposure to feared stimuli with a high presence but full safety. The advantages to this would be that there's, precise hierarchy steps. There's a lot of repeatability, access to hard to arrange situations like, flying or heights or things like that. We combine this with breathing, cognitive coping, as well as between session homework as well. So we see this often done in cases of PTSD, chronic pain, as well as alcohol and drug addictions. With aversive counter conditioning, you can see there's an example here for a treatment for alcoholics, which would be similar, if we were looking at a different drug. But you want to pair an undesired cue or urge, the conditioned stimulus, with an aversive unconditioned stimulus to reduce its attraction or attractiveness. Covert sensitization, ethically constrained use with substance cues or habits. It's often augmented with coping skills as well as relapse prevention planning, which takes us to our last one and our last slide. Treatment of nocturnal enuresis or bedwetting is what we look at. And so you can see the unconditioned stimulus, unconditioned response, conditioned stimulus, and conditioned response example here. And so the bell on the pad, the moisture triggers the alarm, waking the child. Over time, the bladder tension cues the arousal before the urination. And so with consistent use, parent coaching, we tend to have high success. We can fade the alarm as dry nights start to increase. We can track nights, dry or wet, reinforce progress, normalize setbacks. We see this in, I saw this, I should say, in a lot of the kids when I was working in a boys group home. I was a supervisor of a house, and pretty much all the kids there had issues with enuresis, and one of them especially encapresis, which is the pooping side of things. So definitely something like classical conditioning could help with that type of behaviors that we see. And again, though, they're not all necessarily behaviors or acting out. There are some children that just have bladders that develop a little bit more slowly. And so enuresis can be a result of that as well. All right, that is the end of this slide. I will see you all again in another PowerPoint.